move on, what I want to do is give you a little extended example of the kind of text-based investigation in science I've been working to design with my colleagues in Project Ready, the Reading for Understanding grant that I told you about earlier. This unit on methicillin-resistant Staph aureus, or MRSA, has been implemented in middle and high school life science classes. And I want to give you a picture of what the instructional activities for the MRSA unit look like. The unit begins by posing an issue that invites student inquiry. MRSA is dangerous, particularly for youth. Let's make sense of the data to figure out why bacterial resistance is on the rise and what we can do to protect ourselves and our communities from infection. Next slide. In this unit, to investigate the process of MRSA transmission and infection and the causes of bacterial resistance to antibiotics, students read. We've built text sets carefully to ensure that the readings are appropriate levels of difficulty, and students have all the information they will need to develop a causal explanation or model for each phase of the unit. Texts are sequenced to assist in this knowledge development process. We don't clean up the language and complexity of the text, but use specific excerpts and work to intrigue students and support them so that engagement and instructional support in the classroom can carry them through. One of our goals is to model and engage in science reading practices and offer supportive scaffolds and tools that can help students learn to read science texts more powerfully. We are engaging students in a science investigation and at the same time explicitly teaching them to read and make sense of science texts. So we intentionally include multiple representations of text to include the varied modalities involved in science communication. For example, here, students might study graphs depicting the trends in vancomycin-resistant infections in hospital settings over a few decades as they are engaged in understanding how bacterial infections are spread. Or they may read about antibiotic use as well as pore over several documents and models of natural selection in order to consider the mechanisms at play in the emergence of antibiotic resistance. So let's look at the next slide. They might use simulations or models of natural selection from other contexts to think through and model the evolution of MRSA. So here's a text example. As we work, we engage students in revisiting and refining concepts with texts like these and draw their attention to this process to build word learning strategies, as well as an understanding of the role of conceptual change in learning science. Our ideas about science change as we learn. Next slide. A key goal for us is to support science argumentation from evidence across these multiple texts. Because knowledge is critical to effective argumentation, the MRSA module is designed to build student science knowledge. We want students' effort with the text, however, to pay off. So, with MRSA, students read and build knowledge about MRSA transmission and infection, MRSA spread, MRSA evolution, and managing the public health challenge of MRSA. They have multiple opportunities to develop their understanding and practice of explanation and argumentation linked to each of these aspects of study. Reading text, group and class discussion, construction and critique of science explanatory models or science recommendations. These are all a part of the instruction. And the culminating task asks students to determine a course of action to prevent the spread of MRSA in their community. They're required to explain why this course of action will work, which makes them use scientific explanation and reasoning to make the argument. So here's some snapshots of the investigation from middle and high school classrooms. As students are encountering ideas about MRSA and texts of various kinds, they generate inquiry questions that lead to more investigation with more text on this topic. Next slide. For example, after reading about a student who nearly died after having his ear pierced, the students in one ninth grade biology class generated a list of piercing questions that they had about MRSA. Questions that included, should people avoid taking antibiotics to prevent MRSA? How common is MRSA? How do you get it? Next slide. During the unit, key reading routines support explicit modeling and metacognitive work to grapple with the text complexity. The teacher might first model a couple of reading strategies with the text. Here, a graph called MRSA skyrockets. And then the teacher will typically give students time to work to annotate the text on their own, using a bookmark of reminders about reading strategies that they can use, which they've worked to develop as a class in prior lessons. You're seeing the bookmark right there with the arrow pointing to it, and you'll have a close-up version later, and there'll be one in your collection for today. Moving on. A key principle of instruction as our work is making thinking and problem solving a public shared enterprise. Not only are students asked to share what they're thinking, but how they are figuring things out. There are abundant pair and small group and whole class conversations that focus on both how to make meaning of text, as well as the tentative ideas students are coming to as they read. We call this metacognitive conversation and work to support students in identifying what they find confusing, such as challenging vocabulary, and working to clarify and make meaning with the text. The classroom becomes a place where puzzling things out is the key activity, whether puzzling out what the text says and means, or puzzling out what it implies for how MRSA is transmitted or evolves resistance over time. Inquiry is the constant modality of instruction. Next slide. Collaboration is the other constant. Students are constantly working together to make meaning of the text and of the science simultaneously. Lots of documentation of student ideas going on as well. Next slide. Class discussions draw out students' emerging ideas and questions instead of what is more common, which is asking students to rehearse and recite facts drawn from the text or from prior lessons. So here, the questions are about what that reading helped us understand, what new information we're acquiring as we read, and so forth. Students have multiple opportunities to engage in a key inquiry practice of science, developing explanatory models. Here we see a middle school class's first efforts to develop a model after they have read and worked to make meaning with multiple texts. Students will work in groups to develop explanatory models, then share these models with the rest of the class. Discussion of the various models developed in different groups will then stimulate further inquiry. What's the best explanation given the information and data we have from our reading? How do we know? Next slide. So reading and discussion and explanation spills into more investigation with more text centered on the inquiry questions students have been generating.